Welcome. In this video, we will demonstrate how you can use an identity layer as a gatekeeper for your AI, so you have total control over its mechanisms. Right now, every company is rushing to put AI copilots into the hands of their employees. The productivity gains are incredible, but the biggest challenge facing security teams today is visibility and control. How do you guarantee that an autonomous AI agent doesn't accidentally expose sensitive data or override critical files just because a user asked it to? You can't just rely on the AI's internal safety prompts, you need hard structural guardrails. Let's take a very common example in an enterprise scenario. You have a sales team that wants to use AI to quickly read and summarize corporate data. They want the AI to answer questions like, what is our key differentiator over our competitors? Or what markets and segments are our core target audience? You need fast, read-only access to massive amounts of internal knowledge. On the other hand, you have an engineering team that actively maintains this knowledge repository. They want to be able to instruct the AI to actually apply the change, rewrite documentation, and update core files. What we absolutely cannot have is a situation where an unauthorized user, like somebody from the non-engineering team, accidentally or maliciously instructing AI to apply a permanent change. We need a way to enforce least privilege without building a completely separate AI tool for every department. This brings us to a solution. If you look at the architecture flow on the screen, you'll see a clean two-phase approach. It starts with the application. When a user asks the AI to take an action, the AI plugin first authenticates the user against the Okta authorization server. But Okta doesn't just issue a generic access token. It inspects the user's identity and injects custom claims directly into the token. In our setup, it identifies whether the user belongs to the engineering team or the sales team, and then bakes that exact group identity right into the token payload. We now move into the enforcement phase. Before the AI is allowed to touch the local file system or the target resource, the request is intercepted by a local MCP Gatekeeper server. The gatekeeper doesn't care what the AI wants to do. It only cares about the custom claims in the Okta token. It evaluates the token and performs a strict group check. Let's see this live in action. Before we see the AI in action, let's take a quick look at under the hood of our Okta dashboard and see how these identities are configured. We'll be testing this scenario with two specific user profiles. The first one, a user called AI read-only. As you can see here in the profile, they are part of the sales team. And because they're part of the sales team, they have automatically been assigned the app we are testing today. Next, we also have another user called AI code change, and this user is part of the engineering team. Based on their group assignment as well, they have been assigned the Okta AI plugin. However, unlike our sales user, this group membership will permit them to be able to make changes to the system. Let's also take a look at the custom authorization server that makes the gating possible. Here we have a server named Enterprise AI Governance, and under the access policies, we have a very standard set of policies that allow for all scopes. Under the access policies, we have very standard set of policies that allow for all scopes, but the magic here happens under the Claims tab. We have configured a user groups claim. This means that whenever an access request is made by the AI plugin, Okta evaluates the user's profile and passes a specific group, whether that's sales or engineering, directly into the token payload as part of the claims. This is the exact data the AI gatekeeper will use to enforce permissions. To prove this, I'll also be demonstrating how, using the token endpoint, we are able to inspect the claims information for the user that's baked right into the JSON Web Token. The payload will output our custom claims with the user's group, and this is exactly what will help bridge the connection between enterprise identity and the AI environment. Okay, time for the demo. For the demo, I'm using Visual Studio as the IDE, and also I have Kilo Code as the AI plugin. But it is important to know that any other AI plugin or IDE would work equally well. Let's start with looking at the MCP server that has been configured for this demo. This MCP is running locally The MCP stands for Model Context Protocol, which is an open standard that allows us to securely expose tools to the AI. Rather than giving AI unrestricted access to the local file system, the MCP acts as a mandatory intermediary. This architecture actively prevents AI from bypassing our instructions and attempting to write files directly. So it exposes only governed capabilities, serving as a hard enforcement point that validates Okta identities before any action is executed. So let's see this in action. First, let's start with checking our current access by asking the AI to do a token check. As you can see, there is no active token or session at the moment. The AI recognizes this missing token and prompts us to log in. So let's do the authentication and start with the AI read-only user. So to begin, I initiate the authentication flow using our AI read-only account. As shown on the screen, the username and credentials are entered and the session is successfully authenticated. With the session established, the next step is to inspect the active identity context. I prompt KiloCode AI to retrieve the active session tokens and report the token attributes currently associated with the authenticated user. I will fast forward through the AI's reasoning process to focus on the outcome. As shown, the AI successfully retrieves the session token and identifies the associated claims. In this case, the token includes the expected identity information, which aligns with what we previously observed on the Okta dashboard. The AI also enumerates the available claims, the group membership associated with the authenticated session. Next, let's evaluate how these claims affect the AI-assisted operations. I'm going to go ahead and ask the AI to modify the sample file by appending a TLDR section to the existing document. The AI begins by reasoning through available tools exposed by the backend service. It determines the appropriate execution path, respects the platform's security boundaries, and confirms that it has successfully read the target file. It also understands the requested operation to append the TLDR. However, when it attempts to perform the right operation, the request is denied by the Okta governed access controls, as can be seen. The AI explicitly reports that appending the TLDR is blocked because the governed right policy requires membership of being in the engineering group, while the current token contains only everyone and sales group claims. As a result, the AI can generate the proposed TLDR content, but it cannot modify the file itself because the authenticated identity lacks the required authorization. So now let's repeat the same workflow using the account with elevated permissions or using an engineering account. On the backend terminal, I'll go ahead and authenticate the same using the AI code change account. Once authenticated, I will again ask the AI to retrieve the active token information and display the associated claims. For the purpose of the video, I'll fast forward through and come to the part of where the output is shown. At this time, the AI retrieves a token and identifies a different set of claims. In addition to the standard claims, the token now includes membership in the required engineering group. With appropriate authorization present, I once again instruct the AI to append the TLDR section to the same file. The AI processes the request and evaluates the applicable access policies and determines that the authenticated developer satisfy the governed right requirements. Therefore, it invokes the Okta governed right capability, performs the file modification, and completes the operation successfully. Finally, the AI confirms that TLDR section has been successfully appended to the document. This demonstration illustrates how AI agents can be governed using identity-aware authorization enforced through the IAM platform. Rather than relying solely on application logic, the AI evaluates the authenticated user's token claims and authorization policies before executing sensitive actions. The result is fine-grained policy-driven control over AI capabilities that can be readily integrated into enterprise environments.